Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design, through coding and development, to testing, using the PowerBasic Windows compiler. Today we will continue our project to create our own web browser. This was our application at the end of the last video. We have created a very minimalistic web browser. This web browser supports a number of HTML tags. Principally the title tag to allow us to show the name of the web page in the tab, plus the paragraph tag to show the hello world on our browser control. Additionally, we have supported the header tags between header 1 and header 6 to show a range of different font sizes on the control. We are not going to support any additional tags today, but we are going to expand support on the tags we already have, plus to fix a couple of small issues with our browser. The current dialog can be resized, and the objects within the dialog will resize accordingly. However, as you can see, it will not redraw the control. So we'll tackle that first. When our control is redrawn, we want to reload the web page. So to make life a little easier, we're going to use the substitute command again to allow us to have a shorter path to our web page. So if we run the command.exe to bring up our console window, and if we give our substitute command the two parameters, the drive letter we wish to substitute, and the path we wish that drive letter to refer to. Now any reference to the Z drive will take us straight to that folder. So first of all, we're going to handle the resizing problem. If we have a look at the event handler, the callback function, we can find the WM size section. This is a section that handles when the dialog is resized. We already have logic in here that will resize the controls themselves. Now at the end, we want to re-render the page content. First of all, we will get the URL the user has actually entered and store that in the URL variable. Then we can call the existing function render the HTML, passing its three parameters: the path to the URL, the handle of the dialog, and the handle of the tab control. If we try running this now, and we put in our path, and if we resize the control now, we will see that the web page is re-rendered on screen. So that's one problem solved. Next, we will look at the paragraph tag. At the moment, we have given a very short-lined paragraph. If we give it a larger paragraph, we have now added a paragraph whose text is much longer. This text is all in one line. As you can see, if we expand the size of Notepad. So if we save that and try running our application once more, we can see that the long text runs over the edge of the control, and we have no scroll bars to allow us to scroll and view the content. If we make the page larger, it will then be displayed. However, we want the paragraph text to occupy only as much space on the line as it actually needs, and to fold any additional text down to the following line. So we need to make a change in the logic of rendering our text. So let's go back to the code. In the function that displays the dialog, this is where we add the graphics control, and we use the graphics attach command to let PowerBasic know that all subsequent graphic commands are going to be pointing towards this control. The graphics control gives you some very powerful functionality, and some of that functionality is to do with word wrapping. If we add a single line of code, graphics set word wrap. This instructs PowerBasic that if the text is greater than the space available horizontally on the control, it will wrap it around to the following line. So let's try running that code now and see how it works. So we can now see our long piece of text has indeed been folded down to the second line. If we bring the size of the dialog in further, we will see it also folds that again. So dynamically, by adding this one line of code, it will quite happily fold the text down to the following line. However, if we make the dialog shorter in height, then we're losing some of the text, and we have no scroll bars to allow us to see that text. So how can we handle that? Well, the graphics control has something else it can do to allow us to do that, and that's to set the size in virtual mode. We already know that the size of our graphics control is going to be 600 wide and 250 high. If we use the graphics set virtual command and set the width to be as it was and the height to be multiplied by 3, this gives the graphics control more scope for handling text which disappears off the bottom of the screen. If we try running that code now, and you'll now see that we now have scroll bars, both horizontal and vertical. So if we make the height of our dialog shorter, we can scroll down to see the rest of the text. If we maximize the screen, we can see this gives us a bit of a problem. Our control does not appear to have resized correctly on the screen. We still have the vertical scroll bar, but we've lost the horizontal scroll bar. So what can we do to handle this problem? Well, as this is happening within the resizing, we need to look at the resize controls function. The resize control function is what we're using to actually change the size of each of the objects on the dialog. Because we have our graphics control now set to virtual, before we do any resizing, we want to change that back to fixed size. And we want to set up a couple of variables to keep track of the width and the height of our graphics control. And once our controls are resized, we want to get the current size of the graphics window. And we will store those values using the graphic getSize command into the wide and high variables. And now that we have that in place, we can again use the graphics set virtual command to set the size of our graphics window virtually. So let's try running that code once more. So the HTML page is now on our dialog. If we maximize, we will see that our graphics control has now successfully resized itself correctly. And we have the vertical scroll bar. If we minimize it again, we'll see that it's again displaying correctly. So we now have a graphics control which emulates word wrapping. And when the dialog is resized, the graphics control behaves accordingly. However, if you've done any coding using HTML tags, you'll know that there are a number of tags which have attributes. The paragraph tag has a number of optional attributes. For example, if we put the align attribute in our paragraph tag, where we're printing hello world on the dialog, this align attribute allows you to set the alignment to either be right, left, or center. Because this attribute is within the tag itself for the paragraph, if we ran the code using this, it would no longer pick up the paragraph tag. So our hello world is no longer appearing. So at the very least, we have to actually cope with the fact that there may well be attributes with tags. So let's go back to the code and set it up so that it will cope with attributes being there. So we're going to have a look at the render HTML tags function. So in order to handle tags which have attributes, we need to make a change to the render HTML tags function. This is a rendering engine. So we're going to add two new local variables to allow us to handle attributes. A string variable to hold the contents of the attribute, and a long variable to contain the starting position of the attribute command. So after we pick up the tag itself, which is held in the command variable, we now want to pick up the value of our attribute by getting the position of the first space. So our tag could well be a paragraph tag and have an attribute of align equals center. So we can use the inString command to pick up the position of the first space, which would give us this location here. If the value returned by inString is 0, then there are no attributes. If the value is greater than 0, then there is at least one attribute. And we can use a simple if statement to determine that and to pick up the value in the attribute string by using the $! Command to take the command string and start it at the position we have determined that the attribute begins at, and then use a trim command to trim off any leading or trailing spaces. This will populate the attribute into the attribute's variable. Having got that far, we now have to trim the attribute away from the command variable to allow us to return to just having the p tag. We can do that quite easily by using the parse command, looking for the first space from the left-hand side of the string in command. This will allow us to support tags which have more than one character. For example, when we get onto other tags, for example, the table tag is comprised of the word table. So if we try running our code now, this will allow us to display the web page as designed. Now we're not doing anything with the attribute yet, we'll leave that for a later video. The next thing I want to do today is to handle the pulling back of the tag value. And the moment we're determining the tag value in 3 lines of code, getting the start, the end, and pulling back the value from our HTML and putting it into, in this case, a title variable. We're doing this in a number of places and it's crying out for a common function. So we're going to create a common function called getTagValue, which will take 2 parameters, the starting position and the ending tag value. For example, for title, it would show like this. So let's now create this new function. Creating common functions makes the code much easier to read, and it's also more efficient from the point of view of maintenance. Should you need to change the way we get tag values, we would only have to change one function. So within this function, we're going to put the same logic as we had before. We're going to work out the starting position by using the inString command. We're working out the end position, again using inString, and the return of the function will be the value extracted from the HTML global variable using the $$ command, and the values of the starting and ending position. So as we've used this function for the title tag, we can also use it for the paragraph start tag. And again, this is replacing 3 lines of code with 1. So let's try running the code again now to make sure it's returning the same values. And there is our code displayed in our browser window. The final thing we'll do today is to amend our browser to support drag and drop. One thing you can do with a standard browser is you can drag an HTML page onto the browser and it will be displayed to the user. So how can we support drag and drop on our dialog? If we have a look at the callback function, we can add in a new event. And we're going to add in an event called WM_DropFiles. This will be the event that's triggered when something is dragged and dropped onto the dialog. As it's always possible that the user may drag more than one file at a time onto the dialog, our first task is to work out just how many files have been dragged. And we're going to use a Windows API call called dragQueryFile. This takes a number of parameters and will return the number of files that have been dropped onto the dialog. So for the moment, we only want to support a single file being dropped at a time. So we'll do a check on this file count to ensure that it equals 1. If the value does equal 1, we now have to call another API call called dragQueryFile. This call will populate a file name variable, and this will be the path and the file name of the file that has been dropped on the screen. Since we're only supporting one file, the item number is always going to be 0, as the count of files starts at 0 and works up. Now we've created a couple of local variables here, which we will create in a moment. But let's push on with the code to finish off the handling of dropping of files. Next, we will use another Windows API call named dragFinish. This tells Windows that the drag and drop has now been completed. And we can now take our file name, which is our URL, and update the graphics control with this single file. So we're populating our URL variable with the value that comes out from the Windows API call, and we're then setting the text in the URL control on screen to be that value, and we're calling the render the HTML function once more with its 3 parameters: the URL we've just picked up, the handle of the dialog, and the tab value. So this one section in our callback function, our event handler, should be enough to handle dropping of files. So let's create those local variables now. Having added this event into the event handler, there's one more change we have to make, where the dialog was set up in the first place. So we go back to the Lite Browser function. There is another Windows API call which has to be inserted here, and that is the drag accept files command. This takes 2 parameters, the dialog handle and the value true. This sets the dialog up to accept files being dragged onto it. So if we try running the application now, and we move the application up, and we bring onto the screen our HTML page. If we now attempt to drag this on to our browser, it will now display quite happily on screen. So what we've achieved today is we have enabled drag and drop on the browser. We have also amended the paragraph tag to allow the text to be folded round if the screen is not wide enough. So we have achieved word wrap, and we have set the graphics window to be virtual. This means our graphics window is actually larger than what appears on screen. So should our screen be smaller than the text, we have a vertical scroll bar to allow us to scroll down to view the extra text. And we have also amended the resizing events to allow the graphics control, albeit virtual, to be resized correctly. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.